Alright, in this video I'm going to be going over Module 16.2, Explain 1, and I'm on page 800. So let's get started. Solving exponential equations algebraically. In addition to solving exponential equations graphically, exponential equations can be solved algebraically. One way to solve exponential equations is to rewrite them in logarithmic form. Another way is to use the property of equality for logarithmic equations, which states that for any positive numbers x, y, and b, where b is not equal to 1, log base b of x equals log base b of y if and only if x equals y. So what they're saying here is, let's say we had log base 2 of x and log base 2 of 4. Well, the only way that this would be true is if x equaled 4, if these two values were equal. So you can, in some sense, you could say you could drop the logs and you could think of this as x equals 4. Right? This is only true, these are only equal if and only if the inside arguments are equal when you're given the same base. Okay, so let's see how we're going to solve these. Example 1 says, solve the equations, give the exact solution and approximate solution to 3 decimal places. So it wants the exact solution, which I'll show you what that looks like, and an approximate. So for A, we have 10 equals 5e to the power of 4x. And so what we can do is we can divide by 5 to both sides. We're going to try to get that e by itself. Okay, and I get 10 divided by 5 is 2 equals e to the 4x. Now when I have this, if I take the ln of both sides, ln of this side and ln of this side, what we end up getting is ln of 2 equals ln of e to the 4x. Now remember that ln is just log base e, and if we have log base e of e, these will cancel each other out, and I get ln of 2 equals 4x. So now we're here. And what we're going to do is we are going to solve for x by dividing by 4. So if we divide 4 to both sides, we cancel out those 4s, or 4 divided by 4 is 1, and I'm left with 1x. So my exact answer that they ask for is this right here. And then if we were to punch this into a calculator, so ln of 2 divided by 4 would give me 0.173 approximately. And it does say 3 decimal places, so that's why it's approximated to the 3rd decimal place. Now if I flip the page, let's try example B. B says 5 to the power of x minus 4 equals 7. So again, we're going to try to isolate the expression that is raised to the power of x, that exponential expression here. So we're going to add 4 to both sides. So if we add 4, sorry about that, add 4 to both sides, then this negative 4 and this positive 4 cancel each other out, and I get 5 to the power of x on that side. And over here I get 7 plus 4, which is 11. So what we have is we have log of 5 to the power of x equals log 11. They took the log of both sides, so take the common log of both sides. And now we can use our exponent property, right? This is an exponent, and so where can we move that exponent? We can move it to the front. So here I have x log base 5. And since I'm solving for x, I can divide both sides by log 5. So if I divide by log 5 here, and I divide by log of 5 here, I get log 11 over log 5. So this is my exact answer. And then if I go ahead and punch this into a calculator and approximate it, I get 1.48989 and so forth. And remember, the direction said to round this to the 3rd decimal place. So 3rd decimal place is here. If I round this up, that's going to be a 0, which rounds this to 9. So I get 1.490. Okay. Now the beauty of math is that you can do this a lot of different ways. And in fact, when we were going through the steps of what the book had you do, if you notice right here, I kind of paused or stumbled a little with saying log of 5 to the power of x, because what I would have done, I want to show you. So here we have 5 to the power of x equals 11, right? We added 4 to both sides and we got to this point. Now what I would do is I would take log base 5 of both sides. So the log base 5 and 5 cancel, and I just get x equals, and over here I have log base 5 of 11. Now, how do we punch that into a calculator? Well, remember, we use change of base, which is log 11 over log 5, or ln 11 over ln 5. Now, if you notice, this is this. So it doesn't matter which way you do it, you're still going to get the same answer, that approximate answer of 1.490, and you're still going to get the exact answer here. It's just that I used taking log base 5 of both sides in order to eliminate that 5 here. They took common log of both sides, used your exponent property to move that x here, and then divided by log base 5. Either one is correct. Okay, I'm going to move on down to the your turns and do these with you. So number 4 says solve the equations, give the exact solution and the approximate to 3 decimal places. So let's try to isolate the exponential term here, which is e to the power of x minus 1. So first I'm going to subtract 5, and I'm going to get 2ex minus 1 equals 80 minus 5 is 75. And now I'm going to divide by 2 to both sides, and I have e to the x minus 1 equals 75 divided by 2, and I'm actually going to, sorry about that, I'm going to leave this as a fraction for now. Now, how do I get rid of this e? I need to take log base e of both sides, right? Which is ln. So if I take the ln of both sides, then this ln and this e will cancel, and I get x minus 1 left on this side, and I get ln 75 over 2. And the last thing to solve for this is I'm going to add 1 to both sides. So my exact answer is ln 75 over 2 plus 1. We do need to approximate that solution to 3 decimal places, which gives us 4.624, and the next decimal place is a 3, so we keep it as 0.624. All right, so number 5. Number 5 says 6 to the power of 3 to the x, and I'm going to do this using the common log way instead of taking log base 6, which is typically how I would do this, but I'm not going to for this. For the sake of this, I'm going to show you how the book kind of would have done this. So they would take log base 6 to the 3x equals log of 12. I'm sorry, I think I said this wrong here. This is log of 6 to the power of 3x, not base 6. This is base 10. I took the common log. And now using my properties, I'm going to make this exponent the coefficient here. So I have 3x times log of 6 equals log of 12. And then to isolate the x, I need to divide by 3 and log of 6. So divide by 3 log of 6, the 3 and the 3 reduce, the log 6 and the log 6 reduce, and I get x equals log 12 over 3 log 6. And again, we need to plug this into a calculator and get that approximate solution to 3 decimal places. So we get x equals 0.462. There we go. All right, good luck.